Our presenter today is Greg Shanos, PharmD. That's a doctor of pharmacy. I'm not sure I got the title correct, Greg, so feel free to jump in and correct me there. Greg is also the NASA JPL Solar System Ambassador, and his presentation will be part one of Observer's Guide to Mars 2022, and this will be the visual observing part of the presentation. So Greg, I'm going to stop sharing and you can go ahead and jump in. All right. Still there, Greg?
Yeah, Greg, we don't hear you.
Yes.
Okay.
I exited out and came back in so I could
Okay. All right, Greg, the floor is all yours.
Okay, let me get here.
If you're ready.
Yeah. All right, it's on.
I guess the first question is, what does PharmD stand for? Since Chris was trying to introduce you and you weren't here.
Oh, Doctor of Pharmacy, yeah.
Right.
It's the new standard now for pharmacists. Do you have the can you see it or not?
Nope.
The presentation?
No.
No? Okay,
right now.
share screen. Share. Can you see it now?
Yes,
Yes.
indeed.
All right, good. All right, we'll put reading view. All right, and now I'm on the side. Okay, good. I exited out and we entered, so that did it. Okay, so thank you very much. I'm happy to be here. I'm a skyscraper member that left for Florida in 1990. I got married and my wife had plans to move to Florida, so I became part of the plan. And since COVID, I rejoined skyscrapers and I learned of all these other great astronomical societies in New England. So I joined ASGH right around the time of COVID. So here I am. So Mars is going to be coming up. Has anyone seen Mars now in the morning sky? Oh, you have. Good. And what I'm going to talk about is basically, I'm not going to talk about, like the rovers there and the helicopters and all the cool things, NASA's done, landing there. What I'm going to talk about is what we can actually see from planet Earth with our telescopes. And I'm doing a time, so I get that myself. Okay, so first part is visual and sketching Mars. Okay, so this is the layout for tonight. Basic facts about Mars, orbits and distance, Martian features as seen from Earth, telescopic visual observations, drawing Mars, use of filters, and scientific value. So just a few basic facts. Mars, of course, is the fourth planet from the sun, named after the Roman god of war. The Greek god of war is Ares. A day on Mars is about the same as on Earth. It's actually 37 minutes more on Mars. A year is nearly 2 Earth years long, 687 days. It's half the size of the Earth. It's 4212.3 miles at the equator. It's about 8,000 miles. So it's half the size, about the same land area. Gravity is 38% that of Earth. Axial tilt is 25.19 degrees. And if you remember, Earth's tilt is about 23.5. So therefore it has seasons, which is really cool, just like the Earth. 2 poles, north and south. The south poles are most readily visible. The atmosphere is mostly 95% carbon dioxide or dry ice, 3% nitrogen, 1.9% argon, trace levels of water vapor, oxygen, carbon monoxide, hydrogen, other noble gases. The pressure is only 1% that of Earth. So it's a very hostile environment to humans. We can't breathe the air on Mars, and we have to have pressurized. Temperature is negative 195 Fahrenheit to a nice comfortable 70 degrees Fahrenheit. And it has two moons, Phobos and Deimos, which are most probably captured asteroids. And what's interesting is Phobos is Phobos in Greek, which means fear, and Deimos is panic. So the god of war would instill fear and panic. So the names of the moons are chosen very well, I think, right? Because the god of war would instill fear and panic in everybody. So those are the names of the moons. Okay, so orbits and distance. So Mars goes from 35 to 63 million miles away at opposition. And then this is the maximum, 128 to 142. So if we look down upon the solar system, we see the Earth, the sun, the Earth, and Mars. And if you notice the Earth's orbit is pretty circular around the sun, and so's Venus and so's Earth. So, the ancients believe, the planets orbited in perfect circles. But Mars was the real fly in the ointment, because they couldn't predict the orbit of Mars, because look, it's pretty elliptical compared to Earth, right? So being an ellipse, at times it's closer to the Earth, like here, and at times it's further away, okay? And Kepler, of course, determined, the elliptical nature of planets. So when it's within 35 to 63 million miles, it's right here. And then when it's further away, it's 128 to 142. And it shows this retrograde motion. And I found this video on YouTube, which is actually amazing. It really shows it well. This is this image here. Here's the sun. Here's the Earth in blue, and here's Mars in red. And when you see the video, notice as the Earth and Mars get closer and closer to each other, right? All of a sudden it starts this retrograde. It moves backwards in the sky. And this is actual data, by the way. This is not a simulation. This happened September 23rd, 2020. This was the last apparition. So notice when they're very close together, it starts going backwards in the sky. And then as it starts to separate now, right, it starts going forward again. Isn't that cool? Let's have a look at that one more time.
Greg?
Yeah.
You want to take questions as you go or at the end, or what?
I could take them either way. I'll stop at certain points.
All right, I have a quick question.
Oh, sure.
The retrograde went so fast, I wasn't paying as much attention to it because I was watching everything else. How many days long is the retrograde motion on average?
I don't know. Let's look. It starts
Sometime in September, I think.
Let's see, it'll say right there. Good
Yep.
question. Okay. September 13th, say, right?
September
And
9th
then
and November 15th, it said.
And then it ends, it'll say when it ends.
15th.
Right there. No,
Right.
November 15, 20, something like that.
Yeah, on
So-
the right side of the screen, it says November 9th to 15th.
Oh, no, to the 15th. Okay. I didn't notice that.
So
That's
it's a
good.
lot longer than
Yeah.
I thought.
Yeah, it is a lot longer. You're right. What's interesting too is the retrograde cannot affect human affairs. Astrologers will say what's going to happen to everyone's life when Mars is in retrograde. But it has absolutely no effect on our human lives. But isn't that beautiful? Because when you look at this, that doesn't make much sense. But when you look at, this video, you can see them coming closer together. And then when they're closest, that's when the retrograde begins, when they're really the closest. And then the retrograde ends when they start to go apart again.
So, Greg, I think actually the retrograde happens every time Mars is in opposition to the Earth. Because it's a relative view. It's not necessarily how close they are. I mean, it's the closest during the.
Oh, I see what you're saying. Right. right. Oh, yeah, that makes sense. Yeah, you're right, because here it is at yeah, it's exactly opposite. You're right, Bill. Thank you for that. That was good. So right here, see right here, they're at opposition. See, here's Sun, Earth, Mars. So yeah. All right, very good. All right, so Martian features, a brief history. So this all began in 1871 when Giovanni Schiaparelli, shown here in Italy, in Milan, Italy, saw Mars through a large telescope, and he saw dark and light features, and he thought he saw what he called them canali, and canali means channel in Italian, but it was mistranslated into canals, implying intelligent life on Mars. So that's how all this started. And think of it, canals, right? You wouldn't think canali channel, right? But canali really means channel. And then what another thing that happened during this time was the Suez Canal was completed in 1869, just a couple of years before he made these maps. And this was the technological engineering marvel of the era. And so it was misinterpreted as large-scale artificial structures have also been discovered on Mars, these canals. And Percival Lowell, shown here, took it to a whole other level. You know, he was a very rich Bostonian, and he where it is, yeah. So as how many people have been to Lowell Observatory out? I think it's at Flagstaff in Arizona. Beautiful place, isn't it? Really nice, huge refractor there, and that's where Clyde Tombaugh discovered Pluto, and it's a real great observatory if you've never been there. But these are the sketches he made. So see all these intersecting lines for these channels or canali. And then here's a Hubble Space Telescope view of Mars during the 2003 apparition. And that was the closest Mars came in, I think, like 65,000 years, or was it million years? No, 65,000 years. So it was a long time. And it was only 25.2 arc seconds. And the 2020 apparition was 22 arc seconds. And this one's going to be 17.2. So it's getting smaller and smaller because it's not coming see as close here to the Earth. It's probably a little further out there. So I want to spend a little time on these features here. So albedo. So what does albedo mean? Albedo means reflectivity. All right. So think of a mirror would have a reflectivity theoretically of 100%. All the light that strikes a mirror reflects back. Okay. And a charcoal briquette or freshly paved tar would only have albedo of about 4 to 7%, say average 5%. That's why it appears so jet black, because it's absorbing all the light that it hits it. So here we have 3 types of features. You have the red, which is the color of iron oxide dust. These are the desert regions here. Dark gray is the color of volcanic rock. So this is all volcanic rock. And white is the color of ice. Okay, and carbon dioxide too. So all these have proper names, these things. So I'll go over some of these. Sometimes the orientation, here you see it north, south, east, and west. Here you'll see south up. So if you look here, we see the one thing that stands out is this thing called Syrtis Major. And I kind of give these shapes. This kind of looks like the continent of India. There it is. This kind of looks like the continent of India, doesn't it? Right. So I think of it as the continent of India. When you look at it here, it's upside down because north is here, but this is south being up. That's why. But this is the continent of India. And then coming off of India is Sinus Sabius and Sinus Meridiani. And that's this here, Sinus Sabius and Sinus Meridiani. And this reminds me of a cobra with its hood about to strike. Doesn't that look like a snake coming out? Like a snake charmer from the basket, you know, it's coming out. Then here's the, that's what it reminds me of, right? Does it, if anybody else has some other analogy, let me know, because I like these little analogies, I think of them. And then here we have Margariferous sinus, which is this here. And then you have Aurora sinus. And I think of this as fingers coming down. See, it looks like 1, 2, 3, 4 fingers there. All right, so that's Aurora sinus. And then you have Solus Lacus, which is the eye of Mars. And this shows it really nice. Isn't that neat? That does look like an eye. There's the eye, and then there's the pupil. Isn't that cool? So that's Solus Lacus. And then you have these Mari Serenium, Mari Cimmerium, and Mari Tyrrhenium. And if you look at these kind of look like a snake or a worm coming by. So if you don't like snakes, think of it as a worm. And one thing that's important is what's called a central meridian here, which is right at the center. So when we're looking at Solus Lacus, Certus Major, you're at 297. So you're like right here. And then at 29, you have Maria Threnium, Aurora Sinus here. Oh, and this reminds me of Devil's Tower in Utah, where they had close encounters of the third kind. See, it looks like a little mountain. That's Maria Sedanium and the Lacus, Nilacus lacus. And then the right next to Certus Major is Aria, Arabia, Moab, and Eden. So Aria, Arabia, Moab, and Eden. And then this is the Hellas Basin right here. And what's really cool is you can actually see Olympus Mons, which is the largest volcano in the solar system. It's much higher than Mount Everest, and the base is about the size of Arizona. So it is the largest volcano. It's extinct now. It's not spewing any lava or anything. But where is it? There it is. And you can actually see it. There it is in the Hubble Space Telescope. And then these are 3 smaller mountains here. And this is called the Tharsis region. And then these are amateur astronomers' images of Mars. And this is what I'm going to go through next month, in December, how amateurs, how we can take images of this quality with just a $300 video camera. So it's real easy to do. And all the software is free online, but that'll wait till December. But you can see here some of the cloud features. You can see Mars has weather. Here you see clouds, here you see limb hazes. Isn't that cool? So and here's Olympus Mons here. You can even see it with an amateur telescope. These are basically 14-inch telescopes, because I know these 3 are really big in the field, and they all have 14-inch Schmidt-Cassegrain. So this is with a 14-inch Schmidt-Cassegrain. You can see Olympus Mons, which I think is really cool. So you kind of see the albedo features here: Certus Major, Sinus Sabius, Sinus Meridiani. So we have India, we have Cobra, Margariferous sinus, Aurora sinus, the fingers, Solus Lacus, which is the eye of Mars. And then you have your worm, which is Mari Serenium, Tyrrhenium, Serenium, which looks here, or a snake, whatever you want to think of it as. And then, so any questions on the albedo features? Because these are important, because when you're sketching Mars, this is what you're looking for. You're looking for these features, these albedo features, as they're called, and that's what you're sketching, really. Okay, the rest of this is kind of in the background. Okay, so any questions on this? Okay. And then here's another view. This is in 2001. This is a Hubble Space Telescope view. And check this out. A lot of times Mars will have a global dust storm, and this will cover the whole planet. And notice that you can barely see the albedo features here. See sinus sabia, sinus meridiani right here. You can barely see that. And then up here a little bit, you can barely see any of this stuff. The ice clouds show through pretty well, but that's it, you know. So you don't want a dust cloud, a global dust storm during the time of opposition when it's closest and highest in the sky and largest in angular diameter. But that did happen in 2018. In 2018, this is a view from the Curiosity rover. It completely engulfed the planet within a few days, and that's what we saw from Earth. So it was really, do you remember seeing that, John, in 2018?
Yes.
The global, yeah.
Yeah. We were at sort of the Van Vleck. There was virtually nothing to see but dust.
Yeah, it looked like this, right? It
Yeah,
just
it was
looked
a lot
like
bigger
an
than a couple-
orangey red. Yeah, exactly. And did other people see it here, or? Okay. So,
How
so
long do
change.
those dust storms typically last? Correct.
They can last months. I remember the
Oh,
one in
jeez.
2018. It wasn't until it was 2-3 months later where it actually started clearing and you could actually see the albedo features like this again. It took several months. Yeah, they can last a long time. Yeah, it's not like a weekend thing or a week-long thing. Yeah, they can last months. Yeah.
long enough that opposition was over and we couldn't see Mars anymore.
Yeah.
Wow.
Yeah, that opposition in 2018 was basically ruined by this dust storm. But it was good to actually experience a global dust storm. We've never seen one before, right?
Hmm.
So in a way, it was kind of a blessing in disguise because this way, at least we got it during our lifetime to experience a global dust storm.
We knew
Okay,
it could
so
happen.
apparent tilt of the poles varies with position, Earth and Mars. Size of the polar regions change. They get smaller in the summer and larger in the winter. So these things here change, okay? The South Pole. Dust appears red, usually during the, dust storms appear red, usually occur during the southern summer and may engulf the planet like here. And then features appear darker or lighter depending on the presence of dust. Right now on Mars, there's a lot of atmospheric dust. It's not a global dust storm like this, but there is a lot of dust. If you look at the ALPA website, which I'll talk about later, they're talking a lot about that. It started September 28th. Okay, so angular diameter. So when you look at Mars through a telescope, it basically, and the high power, basically looks that big. Okay, so when you see these images, you kind of get spoiled. You know, you think you're going to see it this big or this big even, but really, if you look at it, oh, I didn't want that. I lost mine. Oh, there it is. Okay, so approximate view of Mars. So it's basically going to look this big, okay, through your telescope, and it's scintillating too because of the atmosphere. It's going like this the whole time. So it makes it a real challenge to actually sketch Mars and see a lot of these features. Okay, so the size varies from 6 to 25 arc seconds. Maximum size in December will be 17.2. So here it is. So now we're at about 12 arc seconds, getting closer to 13 now, actually. But, and notice it shows the phase too. And then once we're at opposition, you've seen it face on. So you see 100% of the planet. And here's the diameter in arc seconds. These three I would call the phase angles. That's basically the positions of the sun, the Earth, and Mars at any given time. Okay, those are the phase angles. And then here we have astronomical unit, the distance from the Earth to the sun. So notice it's the closest it gets to Earth during opposition. Okay, observing Mars, essential equipment and atmospheric conditions. So I'm not going to go over the whole optical design, refractor, reflector, and catadioptric. And what you want for planetary is this is out. You don't want a refractor because it's too small. What you need is an aperture. You need a large size, and you want a large focal length. Okay, and then what you want to do is allow time for the telescope to reach thermal equilibrium. I love that word. It just means allow it to cool down to the ambient temperature. So because these are sealed systems. When you have a catadioptric, there's a corrector plate here and the mirrors here. So this is completely sealed system. So you take it from your house, which is 70 degrees, out to 40 degrees or 30 degrees. That's a 30 degree difference. You're going to get thermal currents in here as it cools down, and that's just going to add to the scintillation effect. So you want it to cool. These are more open, so this will cool faster. You want the mirrors to cool down to the ambient temperature. So allow time to reach thermal equilibrium. You want a steady mount, equatorial or anti-azimuth. So you can use anti-azimuth in this case. So this is an equatorial mount, which is how the stars move through the sky in an arc. Anti-azimuth is up and down, side to side like that. And then you can buy tracking platforms for these Dobsonians here. So that's not a problem, but you really do need a tracking, because if you don't, it's just going to be drifting out. So you're trying to image it, or you're trying to sketch it. There's no way things drifting and scintillating. You want it rock steady, at least, right in the center of the field. So you want motor drive for tracking. So take time to obtain a good focus. You want to get a microfocuser. Here's the microfocuser on this Meade here. And so once you get a decent focus, you can really home in with a microfocuser. Okay, you want a clear, steady night with excellent scene and transparency. And I'll go over what scene and transparency is in the next slide. Shield from wind, if possible, because what happens is you're watching it, it's rock steady in your field of view, and all of a sudden you get this gust of wind, and it's going like this because of the wind. And that's really bad if you're trying to image too. So try to shield from wind. And the nice thing about this is that observing the planets, light pollution is really not a problem. They're very bright. Moonlight, I've imaged the planets with the moon only with a full moon in conjunction with it being only like a few degrees away. and you could see when you look at it inside the back, the field, the background, instead of being dark, it's just totally lit up with the planet standing right out. It's amazing. You can have haze and high cirrus clouds. These cause no interference. Now, if you have thicker clouds where you can't see the moon, well, that's going to cause interference, but that's about it. But it's very forgiving, planetary, as opposed to deep sky. If you have light pollution and moonlight and haze and all that, you can't see a galaxy visually or with a camera. So it's very forgiving, which is very, very nice. Okay, so you need to have high power. So generally you want 30 to 50 times the aperture in inches. So if you have a 6-inch, 50 times 6 is 300, 8 times 50 is 400, etc. Okay, and then drop back to 30. Now, the best time to observe is during opposition or when highest in the sky. And actually, it's best to observe Mars throughout its whole apparition. All right, that's what I've been doing. And does the ASGH belong to the Astronomical League?
No.
No? Okay, because I belong to a couple of astronomy clubs that belong to the Astronomical League, and you get that nice magazine, The Reflector. But not only that, but you can do these Astronomical League. They give you an award, a certificate, a pin. So they had a Mars award. Well, they still do. I did it in 2020 for the 2020 apparition. I observed Mars throughout its whole apparition. I have 115 observations that I documented, identified the albedo features. I watched the polar cap, the south polar cap shrink as it got closer to opposition. I documented the different central meridians I saw. If you want, I could show you some of these later if time permits, but it's really great. Seeing versus transparency. So this is what I was saying here. Clear night with excellent seeing and transparency. So seeing refers to turbulence in the atmosphere. So scale of 1 to 10. So 5 would be average turbulence. 2 to 3 would be very poor seeing. And then, 8, 9, 10 would be great seeing. So what I would call average seeing would be probably something like this. Poor seeing would be, it's really moving around. And then good seeing is like very little waving in there, okay? And then transparency refers to how clear the sky is. Lowest magnitude star visible. So what is the lowest magnitude star? If there's a lot of haze and stuff, you might lose a couple of magnitudes, okay? And a lot of times this also gives a scale of 1 to 10 too. So you could say, 5 average transparency. If you have a lot of cloudiness or haze, you could have poor transparency, etc. And what's interesting too is these transparency and seeing seem to have an inverse relationship to each other. If the transparency is great, when you get those deep blue skies, low humidity, it's like the perfect deep sky night to look at galaxies or image galaxies, right? The seeing will not be good. You're going to have a lot of turbulence in the atmosphere, which is crazy, but that's the way it is. And the reason being is you're looking at the planets under high power, and so you're increasing the turbulence in the atmosphere. And when you're seeing deep sky objects, you usually under low power and you have a wider field, so the seeing isn't so bad because you're looking at it under low power. So take time, like I mentioned, to obtain a good focus. Where's my... There it is. Take time to obtain a good focus and continuously refocus because the atmosphere continuously changes. So just because you get a good focus and you're observing every minute, like when I take images, I take 60-second images, I stop and I refocus. I don't just keep taking images and it's amazing how after 60 seconds, the atmosphere change. You got to, with the micro focuser, really fine tune it. And then, okay. And then here, you have something called an ADC, an atmospheric diffraction corrector. Has anyone heard of this? This is basically used for if you're imaging more, but you can use it visually too. And what you do is you put these two together and then separate them out. And it's supposed to correct for diffraction. And here's what they mean by diffraction. When a planet is low in the horizon, like Mercury or Venus, a lot of times you get this blue diffraction here. And if you adjust these, see, it eliminates that. And I have one of these and I've only used it twice. I don't really get that much. Damian Peach swears by this. He really likes it. But if you're in mid-northern latitudes, it's good. He's in England. And but I live Florida, so I'm 27 degrees north latitude. So I'm 27 degrees above the equator. And the advantage of that is closer you are to the equator, the higher the planets appear in the sky. See, so I see them quite a bit higher than they'd be in New England. So you don't really need this if the planets are a lot higher. And Mars right now, if you look just before sunset, it's from Florida, it's almost directly overhead. It's like 80 degrees above the horizon. How high is it, John, in Connecticut? It's probably 60, 70. It's probably a good amount.
It was when I saw it at the Connecticut Star Party at night, Jupiter and Saturn were both fairly high and, considering in the sky, 20 degrees maybe, but Mars was like 7.
70, huh? Yeah,
7.
yeah. And
7.
Jupiter, 7 degrees?
7 degrees off the horizon.
When?
Connecticut Star Party late last month.
Really?
Yeah.
Before sunrise?
No, night.
Oh, no, I'm saying before sunrise. How
You
high
don't
is
think
it?
I get up before sunrise now, do you?
Oh, okay. Yeah, all right. But
And it-
before sunrise, it's really high. And Jupiter's actually very high too. And not around midnight now. So it's the planets are really high. Jupiter and Saturn, and not Saturn, Jupiter and Mars are really high this year, which is really nice. But you can try this. And what do you think of the ADC, John? Do you like it or?
I think it's a little gimmicky, but if it helps, by all means.
Yeah. Yeah, I don't see that it's a huge difference. You know what I'm saying?
I don't know of
Okay.
anyone that makes them besides ZWO, but to have
Yeah.
ZWO, you have to really, drink the ZWO Kool-Aid.
Yeah.
The ZWO cameras, the filter wheel, the focus,
Yeah, I know.
the ASI Air, and the ZWO milk now. Where's my ZWO Kool-Aid? Oh, yeah, here it is, right here on my keychain.
Yeah, I know. I have one of those too.
Yeah, I drink the Kool-Aid.
They do make a fantastic camera, though. That's what a lot of people are using, actually. So
For the money,
knock
they
it.
are very good.
they are very good for the.
CMOS, they probably own the market.
Yeah, oh, they do. And QHY is the other one. Those between those two cameras. Okay, that's December's talk. Okay, so prepare for an observation. If you're going to wake up early like I do to image Mars, you want to know that the sky is whether it's worthwhile. And there's 2 apps for your cell phone and also online. One of them is the clear sky clock. Most of you are familiar with this. So you have here transparency, seeing, and the darker the blue, the better. Okay, so if it's really dark blue, then that's excellent. If it's a little bit lighter, that's like above average. And if it's light like this, it's maybe average. And if it's white, it's below average or poor. Okay, so I like this one better. This one's called astrospheric, kind of a play on words. Instead of atmospheric, it's astrospheric instead of atmospheric. So it's
We
kind
have
of
an ASGH account on Astrospheric because we were beta testers for their chatting feature.
what was that again?
ASGH has a group section on Astrospheric because we were
Oh,
accepted as part of the beta test team for using it for their new feature of chat for membership.
oh, okay, great.
Ostensibly, we're using it for the Van Vleck, just for people, the team
Yeah.
to communicate with each other, but we use radios now and the cell
Okay.
phones, it's just as easy. So
All
I would
right.
suggest any member who uses Astrospheric, whether it's the website for free or the free app or the paid app, they can
Right.
join the ASGH section and I'll prove it.
Oh, cool. Okay.
And you better know the Clear Dark Sky site. It's been on the ASGH website for 20 years.
Yeah. Okay. So this thing does the same thing. See, transparent cloud coverage, and I cut it off here seeing, but I like this because it gives a nice map of where you're located. And Hurricane Ian hit right here, the eye. So it was too close for comfort. But either way, so here, notice this would be absolutely excellent. This is above average. This is average, and that would be below average, okay? So notice I was observing 4 a.m. on this day at 4:51. And see, so we had above average weather condition, seeing conditions. So the whole idea of this is before you go out observing, do a little recognizance, see how the transparency and seeing is in your area, because, and these are surprisingly accurate. I've gone out when this thing was more toward the white end, poor seeing. I go, oh, let me just look. And the seeing was really poor. And sometimes this maybe overdoes it a little bit. It may only be average, and it says above average, but it's still pretty accurate. These are very accurate. So if it says it's good, nice and dark blue, go out and observe. And another thing you want to check is the weather underground. This cracks me up because the weather's gone underground. And what's interesting is jet streams are fast flowing narrow air currents in the atmosphere about 6 miles above the surface, and they form boundaries where temperature differences. So you get temperature differences combined in the troposphere. You can read all this yourself, and the stratosphere. And so the whole idea here is that when jet stream is above the area, your seeing will be more turbulent. And here's the miles per hour of the wind, see? So if it's red here, it's much worse. Blue is a lot less, but these change every day. So watch this, and I've seen it like come over Florida, and then 2-3 days later it's gone. So it's usually not over Florida all that much. It hasn't been all summer, which is fantastic. So check this website and make sure the jet stream is not above you too. So now you got two things to look at: the astroperiodic clear sky clock and the weather underground. Now there's this excellent free program called WinJupos. Okay.
Greg, may I interject before you go on to WinJupos?
Yeah.
He's absolutely correct about using these sources, but let me add a little bit of New England wisdom. Use at least two, if not all three, because I have seen occasions where Astrospheric has bold-facedly lied to us.
Mhm.
We're ready to go observing. We had clear skies and all of the sub layers. It does go into the sub cloud layers of the atmosphere too, into lower atmosphere, the upper atmosphere. It really does a fantastic job. But we got there, it was cloudy as all get out, and it was all blue things. Now, clear dark sky does the same thing, but you have to click on each square. It brings you to a website that shows you your position for wherever that calendar was made. And ours does show the Van Vleck on our calendar. We actually have two, one for Hartford and one for the Van Vleck, observing on the public observing page. And it will show you for each one of those layers, for seeing, for transparency, and for cloud cover. But you have to backspace, get back to the main clock to go to the website for the next one, whereas Astrospheric is so much easier because you just click on the square and it just shows you the change immediately. But it's an application versus a web page.
Yeah.
But definitely check all three. And
check all three. Yeah.
I'm a double thumbs up for WinJupos as well. I'm a big fan.
Yeah, isn't that a great program?
It really is.
It does have a significant learning curve when you're doing, derotation and all that stuff. But for visual, it's really easy. All you have to do is just input your latitude and longitude, enter the planet, and hit real time, and it'll tell you exactly what face of Mars is out, what face of Jupiter is out, the Saturn ring tilt angle. It tells you everything. So it's really, really a fantastic program.
It works for all the
And-
planets.
Yeah, it works for all the planets. Yep, it has all the planets. And then if you hit this one, Ephemeris here, it tells you the diameter. Look, it takes 11.2 minutes of light to get from Mars to the Earth. And then the phase, which is 86%, then tells you visual magnitude. And then these are these position angle things. Position angle, Julian date. I find that the most confusing thing in the world. Only I think the AAVSO uses that. But okay, so visual observing, color filters. So other than looking at Mars, you want to look at through filters because filters will bring out different albedo features, which is cool. And you can get at Orion Telescope sells these by the set and everything. And they have these numbers called RAT numbers. And so these are the basic filters: red, orange, yellow, green, blue, and violet. And then the red basically is the best filter to use because you get general surface features, dust storms, and notice orange and yellow is basically covered by the red. And then green, you see some white clouds, yellow clouds, and then blue and violet give the upper atmospheric clouds, limb clouds, polar hazes. So in my opinion, if you were to get two filters, the best one to get is the red and the violet. Okay, because this gives you, and I've looked at Mars recently visually, and it's so bright you can just barely kind of make out the albedo features, but you put a red filter on and it darkens it. They just stand right out. And if you look at violet, you can barely see anything, but you can see like white clouds coming through it. And then there's this other thing that Orion has. I bought this. It's only $40. It doesn't break the bank. And this actually works pretty well. It gives a view equivalent to the red filter, if not better. And what it does is it blocks, here's how to read this. White light is between 400 and 700 nanometers. So it's easy to remember, 400 and 700, okay? And if you prefer microns, it's 0.4, 0.7, and then angstroms is 4,000 to 7,000, but nanometers, 400 to 700. And then it lets through about 90% of the light here, but this is what it lets through, and then blocks everything here between 505 and blocks everything here. And then this is all blocked, and that's supposed to give you better images, the polar caps and landscape shading, polar hazes and clouds become visible. So I recommend this. This is a pretty good filter. I was impressed with it. For only $40, it gives a real nice view visually. And I've also put it on my ZWO, and it gave pretty decent images too. Now, there's this phenomenon called blue clearing. And when I had to, when I did the Mars Award, I had to monitor for blue clearing, and I actually saw it. And what it is these albedo features, when you look at them with your eye, they'll appear like this. But then if you put a blue filter, it kind of blocks them out and you really don't see very much, okay? And then if blue clearing is happening, what happens is through a blue filter, it'll appear like this, okay? And originally they thought that there was this violet layer that consisted of aerosols of fine particles in the Martian atmosphere that absorb the scattered shorter wavelengths. But Mariner 6 and 7 in 1969 took pictures through color filters, and there was no diminishing of blue light. So and then Carl Sagan and Pollack presented evidence that blue clearings originate in the atmosphere of Earth rather than Mars. And they tend to occur near opposition, when Mars is closest to the Earth, largest in angular diameter, highest in the sky, therefore increasing the contrast of the albedo features. Could also be due to the phase angle. So, but during the 2020 apparition, I remember seeing when I was imaging, it looked identical to this with the violet filter. It's amazing. So the blue clearing does happen usually at opposition, but it's more of something that's happening on Earth's atmosphere than Mars. That's the bottom line of that. Okay. Oh, remember I said why some of the images, see, this is north, south, east, and west, and these are south, north, east, and west. Okay, the reason being is the telescopes. When you use a Dobsonian reflector, most amateurs were using Dobsonian reflectors, and what this does is it inverts north and south. So south is up, north is down, east is to the right, and west is to the left. Now, when you use a catadioptric, okay, and these are the preferred telescopes for imaging the planets. Since you have a star diagonal prism, north is up, south is down, but east and west are inverted. So west is to the right and east is to the left. All right. And now that people are taking better images, and sending them to the Association of Lunar and Planetary Observers, ALPO, to NASA, to Juno Project for Jupiter. The professional astronomers want north, south, east, and west. North up, south down, east to the right, and west to the left. Okay, and that's the way I always like to image it too. And this was from a slide that Christopher Goh did, one of the world-renowned imagers. And he had, that's like looking at the Earth, instead of looking at it like this as the International Space Station orbits, that you're looking at it like this. You're saying this is the normal view of Earth, not this. See what I'm saying? So people are so accustomed to seeing Mars and Jupiter and Saturn with south up. That's the equivalent of looking at the Earth like that. See, so it's not really the right way. North is defined as up, not south is up. So, but everybody pretty much at Alpo has south up. You look at their journal and everything they publish, south is up. You know, just, I don't know. And then, so how to sketch Mars? So draw a 42 millimeter circle. I don't know why 42 millimeters was chosen as the thing, but 25 millimeter is an inch, 25.4 actually, but 25 millimeters is an inch. Nice and easy to remember. So 2 inches is 50 millimeters. So it's a little less than 2-inch circle, maybe 1 3/4 inch. So fill in the terminator because it usually has a phase unless you're at opposition. And then draw in the polar caps, and then outline the major features, and then darken the features and sketch them in, and then sketch in any clouds you may see. So that's the process that you would use. And here's an example. I can't draw, so I found these on the internet. See, south is up. Everyone loves south is up. Central meridian, you now know what that is right here. Okay, 275 degrees. This was taken 11/21/2007. And notice the time. This is in universal time. So notice this is 25 minutes. So he is not, so when you sketch this thing, don't think you're going to look at it for 2-3 minutes and okay, I'm done with the sketch. You're going to be looking at that and looking at it and focusing and refocusing and taking your time. So he took 25 minutes. Seeing was 5 out of 10 average, 11-inch Mercator gray. Notice he's using filters 23A, which is the red filter, and then high power. And then this is at a different time here. And I should mention universal time. Universal time is the time in Greenwich, England, okay? And which is defined as the prime meridian. And this can be a little confusing because what happens is our time now is October 19th, 2022, 8:29 p.m., right? Now, universal time, it's October 20th, 2022, the next day, 0 hours, 29 minutes, universal time. It's midnight, 12:30 a.m. in Greenwich, England. See? So it's the next day in Greenwich, England. Now, when we turn, to confuse you further, when we turn our clocks back to normal instead of daylight savings, 7 p.m. will be 0 hours universal time the next day. All right. So if this were November 19 at 8:30, this would be November 20, 2022, 1 hour, 30 minutes universal time, because 7 p.m. is midnight. Does that make sense to everybody? See, so, and I've messed this up more times than I hate to admit, but I look at when Jupiter, see, this is universal time. So if you're thinking like a shadow transit of Jupiter is going to happen, one of the moons is going to go across Jupiter, and you're going to see its shadow, which is really a cool thing to see. And you say Tuesday the 21st, right? You missed it, because that's universal time. It actually was Monday your time. And I've done that, so you got to be very careful. Too bad it doesn't have here. Actually, I should email Grisha Han, who's the writer of this, if he could include both. Maybe it would tune into your time on your windows and would give you both. That would be good. Yeah, I'm going to email him and ask him that. That way you know what your time is, local time and universal time, because it can get very confusing and you could miss something because, oh, it's going to be on Tuesday. No, it's Monday your time. So
Hey, Greg,
that's
Go-
universal time. What?
going back to WinJupos, couple
Yeah.
of things to mention to people. You just noted that he is German. Because this is German software, a
Yeah.
number of security programs on your PC will not allow it to install or even download. You have to tell it that it's an approved, okay.
Yeah. Yeah.
And
Yeah.
if
Oh,
you're
yeah.
the owner of the software, you have to say no, but you're a user and you know the guy
Yeah.
who's doing this to allow it.
Yeah, I know that Norton's blocks it. Windows Defender. Are you sure you want to run this program? Run
Yes.
anyway. Yeah. Oh, yeah, I know.
And I
Especially.
have advocated for it on Norton 360, so it is generally approved now for at least one of 5 people, but it also uses a file extension that another program uses. Forgot what it was, but it was a Windows program, as a matter of fact.
I think it's Outlook, John. I think it's an Outlook calendar file.
Oh, yeah, maybe that's what it was.
Yeah. Yeah, you're right. It's really, when you try to update this and install it, it gives you all these blocks. It blocks it. And Norton's actually puts it in, what is it called? Quarantine. And I got to take it out of quarantine and tell it it's safe. And
And if you're not familiar with how to use that security stuff, it's really exhausting just to try and even find it and locate it. What happened?
Yeah.
I've downloaded this thing 5 times now.
So,
The other thing I want to mention is you do not have to be a member of the Astronomical League to get one of their observing programs. You can buy it even for yourself to learn how to sketch and to use it. You just can't get a little pin and a certificate.
Yeah,
that you're a member.
award. Right.
And also,
But that's everything. That's everything, though.
Well, all right. I'm also a member from 2 different clubs, which means I get reflector twice. You can't get it once.
Yeah, I belong to 2 clubs too that have it, and I get 2 reflectors. Yeah,
You can't
there's a
stop it.
digital edition too.
Yeah, that's new too.
Yeah, I like that. I like the digital better because I save it. I call myself a digital hoarder. I save all that stuff, emails and stuff.
BAA as well as
Okay.
digital.
Huh?
The BAA, the British Astronomical
Yeah,
Association.
yeah. Okay, so amateur astronomers or citizen scientists are encouraged to send their drawings or images to ALPO, which is the Association of Lunar and Planetary Observers. ALPO had the name first in 1930s, okay, not the dog food. And this is a professional amateur collaboration. It's a organization that collects people's sketches and photographic images and archives them and gives them to professional astronomers for research. So it's really good. And then the director for the Mars section is Dr. Roger Venable. He's a retired emergency room physician from New York, now living in Atlanta. So he was very helpful in helping me during the Mars Award. And there's also going to be a lunar occultation of Mars. So the moon will go behind Mars from your line of sight, which will be really cool. But I'm not sure Connecticut can see it. I know Florida is definitely out. But if you're in this cone here, you'll be able to see it, which is going to be really cool. Do you know if Connecticut's in there? John or Chris, do you guys know if not, it's going to be really, really close. It just won't go behind it. That's all.
I think we missed it, but
I think
Yeah.
I think it's going to be like Asia and if I remember correctly, it'll be like far western the United States and Alaska that we'll be able to see that. But I'm not sure. I'm thinking of the right occultation.
No, we can see it in Connecticut.
Can we?
In fact,
Okay.
I have it here somewhere, Mars occultation. I think it's, December 7th at 11:01 p.m.
All right.
Ours will be about 5.5 Mars diameters from the surface. So it's about 1 minute of arc, I guess, from the surface.
1 p.m. That's during the day.
No, 1 a.m.
Oh, a.m. Okay.
All right.
11:01 p.m. on December 7th.
Okay. All right, but it says here December 8th, Universal Time. So,
That's right. So it's December 7th.
oh yeah, it's December 8th, right? 1. So that'll be 7, 8, 9, 10.
No, it's 23:01 Universal. 23:01 hour
2301. Okay.
Now,
All right. So,
it'll be 73-degree altitude at a 194 azimuth. So it's really up,
okay.
almost up.
It'll be
Right up.
almost up at the zenith. I know. So I won't. Oh, you guys got to take some photos of that or video. That's going to be something spectacular. Well, hope for clear skies on that one. And that's it. That's all I have. So any questions or? So 1 hour, 24 minutes. By myself.
you did good.
So Greg, would you talk a few minutes about the advantages of sketching over photography?
Honestly, there are no advantages of sketching.
Less than $5 for
The only reason sketching was done was because photography wasn't there. Alpo was founded in the 30s, and people, remember the old days of taking a picture? I talk about this in my December lecture. You had the big extension tubes, and you put a camera to it, and you had the mirror slap, and it was so small and fuzzy, and you could actually get better. You could actually do better sketching it than you could photographing it back in the day, right? But then once the digital revolution came, especially in the 2000s with the webcams, that all changed. Then photography and imaging. Photography usually refers to a snapshot. Imaging is you take a lot of photographs, video, and you align and stack them together and create an image, which is really the photograph, but so there really isn't any advantage, but people still submit. I've seen some images. People still like to sketch. Some people are artistic and would rather just sketch it. And I've seen people sketch the craters of the moon, and you'd swear that was almost a photograph. It's that good. So some people are really that artistic, but very few, So there really are no advantages. I mean, look at this of Sirius Major, and then look at an actual amateur photo image. See, now that tells you a lot scientifically, right? See, as opposed to that. See what I'm saying? So there really isn't an advantage now, but it was the only thing you could do back in the day because photography wasn't there. Film wasn't very sensitive. Even the professional observatories used glass plates, in the 1800s before film was even around. So, but now with the digital revolution, everything is digital, imaging is this. So any other questions?
Greg, why do you think we're not seeing the canals or the channels that like Schiaparelli saw? Because I'm not
good question.
seeing those.
There's actually a Dr. Roger Venable did a 20-minute presentation at the 2021 Alpo conference, and John Silason's was there. And I have that video if you want to see it now. And he actually goes over Hubble Space Telescope, blurs them a little bit, and he actually identified some of the features that he was seeing. Do you want to see that? It's about 20 minutes or not.
Probably not now. It's getting a little bit late, but I would like to see that, but probably not now. It was such a, it was such a big deal at the time.
Oh yeah.
I mean, and it kind of entered the psyche.
At this.
Oh yeah.
Look
but
at that.
I don't see
all
those
these straight lines, right?
Yeah, I don't see those anywhere.
And then these are these are images through a 14-inch telescope. This is the Hubble, okay? But this is, but notice how good amateurs are doing. Here's the Hubble, and here's amateur 14-inch scopes. I mean, isn't that amazing? You got to admit that's really good. And these are very valuable because people are at different parts of the world, so you can get like a complete rotation in a week or so. You can get like a complete rotation of a planet, especially Jupiter that spins in 10 hours. So in 10 hours, different people are in different parts of the world in darkness. You can get a complete rotation from beginning to end of Jupiter in 10 hours. You know what I'm saying? Whereas you can't have the Hubble Space Telescope doing that 24/7, but you can have amateurs doing that. You know what I'm saying? So we're contributing a lot now to science. That's what's great.
Yeah. I mean, what was he looking at that made him see all those
You got to
lines?
see that video. You got to see that video. I'll send the
link.
I'll send the ASGH groups the link to the YouTube video and where to start.
Yeah, that'd be great. That'd be great. Thank you.
And watch it, and you'll see he actually identifies them. He blows them up, and remember that, John?
I do.
Remember that lecture?
Yeah.
Yeah, I'd like to see that. Thank you.
At the top of the mountain or wishful imagination?
Yeah. I know some of them you have to really use your imagination, but some were a little more obvious. You have to admit, some were a little more obvious.
you got people back then that saw clouds in the sun. So who knows?
Yeah. It's just but that's what started this whole
Yeah.
thing with Schiaparelli. He saw these canals, they're really
Yeah.
channels, but then even channels, and then Lowell just took it to the next level, really, and popularized the idea,
Yeah.
and then H.G. Wells with the War of the Worlds and all this
Sure.
stuff. So any other questions?
Greg, could you address, whether you would be able to see any aurora or any of those conditions that we might be?
Well, I don't think there's auroras on Mars, but you can't see clouds. See, right here, limb hazes. Right here, here's a cloud. See a little white cloud forming there, and that you could see move over in a few days if it stays as a cloud. See, and then Olympus Mons is usually clouds above that, and then the polar cap grows and shrinks. So you do see changes in Mars. You do see weather, and now and of course the dreaded dust storms. Okay, now there's dust around Mars too. So.
Well, without a magnetic field, then you're not going to be seeing an auroras per se. Then.
Right. Yeah, there aren't any auroras that have been detected on Mars. Yeah, we spent a lot of spacecraft around there. They would have detected it. Jupiter has a lot of auroras, which is cool. And Saturn even too,
Thanks.
Amazing talk, Greg. Thank you very much. I
Yeah.
really appreciate it. I'm hoping that everybody else enjoyed this as much as I certainly did.
Yeah. Thank you.
Thank you very
Yeah.
much.
Oh, you're welcome.
Thank you.
Thanks.
Yeah,
So
thanks.